I am greeting you from our online classes. I'm still your teacher by name, Ndukwe Amara. I hope you are staying safe wherever you are. Last week, I introduced a topic on classification of organisms to you. We talk about organization of life, where I told you that biologists have discovered more than 1.8 million living organisms. And I told you that there are yet many millions of organisms to discover and still describe them. Then I told you that Aristotle is a Greek philosopher who first made an attempt of classification of organisms. And this man lived in the year 384 BC to 322 BC. We now talk about the present method of classification, which is the work of Carolus Linnaeus, who lived from 1707 to 1778, a Swedish naturalist. And I said that it is his method of classification that we are still using up till today. And I told you that the method of classification of organisms is what we call taxonomy or systematics. The general principle of classification of organisms is called taxonomy or systematics. Then we talk about method of classification of organisms. I told you that in classification of organisms that there are many features which organisms share together, and those features is what are considered in classifying them. Then we now talk about hierarchy of living organisms. I told us that the largest classification of organism is the kingdom. After the kingdom, it follows phylum or division. After phylum, we talk about the class. From class, this next one is order. From order, we move to family. Family to genus, genus to species. These are 7 hierarchy or levels of classification of organisms. I told you that the kingdom is where we find the largest number of living largest number of organisms, where the species is where we get the smallest number of organisms. That is, we follow it from the highest to the least. Then we talk about binomial nomenclature, where an organism is given 2 names, the genus name and then the species name. Then I told us that upon these 7 classifications, which scientists have used this hierarchy of classification, that many organisms did not fit in based on the work of Carolus Linnaeus, who placed organisms in that hierarchy of classification, that many organisms did not fit in. I gave you an example that day, the viruses did not fit in. So, and because of that, many organisms did not fit in, scientists or biologists now grouped organisms into 5 different kingdoms, which I told you that we have the kingdom Monera, kingdom Protista, kingdom Fungi, kingdom Plantae, and kingdom Animalia. I told us still on these 5 classification of 5 kingdoms, yet the viruses could not fit in. Some organisms like the lichen, which is association of fungi and the algae, cannot fit in again. Viruses, we see them as the borderline between plant and animal. These viruses are so small that you can't even see them unless you use a powerful microscope like the electron microscope. So we are going to take that 5 kingdoms which we classified last week, one after the other. You see how organisms are classified. Today we are going to look only at the kingdom Monera. Kingdom Monera is what we will study today. I want you to pay attention in this topic because it normally gives students tough time when such topics comes out in the examination. They don't know where some organism belongs. So pay attention. If you pay attention, you enjoy the topic. So let's look at the first kingdom in the Calorus 5 kingdom classification, the kingdom Monera. These Monera are the simplest living organism. And organisms found there are usually bacteria and the blue-green algae. Monera kingdom, I said that it is the simplest living organism. The organisms usually found there are what? Bacteria and the blue-green algae. They are the people that belong to this kingdom. All bacteria and all blue-green algae belong to kingdom Monera. Have this thing at the back of your mouth. They are very small organisms and are made up of single prokaryotic cells. They are made up of single-celled organisms. That is a single cell. Single-celled single prokaryotic cell. They are single-celled organisms. One cell. They are made up of one-cell organism. Enclosed within a rigid cell wall. In this organism, their cell structure is very simple. There is no definite nucleus. They don't have a definite nucleus. And the chromosome lie free in a particular part of the cell. I want you to notice the characteristics, the main feature of this kingdom. The main feature of the Monera kingdom. One, let me write it out for you, main feature, so that you will not get confused. Main feature of Monera kingdom. Number 3, organisms are microscopic. They are microscopic. You can't see them with your naked eye. Organisms are microscopic. Cell structure is simple, as I have told you. Cell structure is so simple that they lack a definite nucleus. Cell structure is simple with no definite nucleus. With no definite nucleus. Number 2, organism found is, I told you, as all bacteria. Bacteria. Bacteria is plural. If you want to use singular, it's bacterium. So singular is bacteria. And the blue-green algae. Remember, blue-green algae. Green algae are members of this. Make up this kingdom. So remember that in Monera kingdom, their main characteristics is that they are single-celled organisms. That is one cell. Single-celled organism. They can be motor or non-motor. Organisms are microscopic. You can't see them with your naked eye. 3. Cell structure is simple with no definite nucleus. This is the main feature of them. The cell structure is simple with no definite nucleus. Yes. Let's now look at the bacteria. Let's take up the bacteria briefly. Let's look at the bacteria. Bacteria can only be seen through the high-power microscope. Bacteria, just as I told us from the feature that organisms are microscopic. Bacteria can only be seen through the high power of a light microscope. And they are everywhere. You can see the bacteria in air, in the water, in the soil. Inside living organisms, we even harbor them. Some of them live inside us. Even in the eyes, in the nose, in the private organs, they live there. They range in size from about 0.1 to 10 size of bacteria. You see, it's very small, from 0.1 to 10 micrometer. Micro is 10 raised to power minus 6. Micro is 10 raised to power minus 6. You see how small they are. When you get 1, you divide it by 1 million. That gives you a micrometer. You see how small they are. So, and then bacteria have many shapes. We have the one that are spherical in shape. If they are spherical in shape, we call them cocci. Cocci, like this. They have the shape of a sphere. You know how a sphere is. It's not perfectly spherical. So they are just like. So if they are spherical in shape, we call such bacteria coccus or cocci. When they are rod-like bacteria, we call them bacillus. Bacillus or coccus. Bacillus. Then, if they are, some of them can be in chain. If they are spherical but in chains like this, in chains, when they have chains, we call them streptococcus. Streptococcus. Like this, when they are in chains. This is how they are in chains. We call them streptococcus. When they are in cluster, we call them staphylococcus. When they are in cluster form, see that many, very many, they find themselves in cluster like this. They cluster themselves together. That's when we call them, just if we have staphylococcus, we call it based on their shape. They are made like this. Then if they are in spiral shape, we call them spirochaetes. Then if they are bean-shaped, we call them vibrio. Bean-shaped. So if you hear how we pronounce them vibrio cholera, it means that bacteria is bean-shaped. Then, just as we said that bacteria can be motor or non-motor, some of them can move, while some of them cannot move. The motor ones have what we call a flagellum or flagella, a whip-like organ for movement. A whip-like organ for movement. The motor ones, they are made up of what? Flagellum, which is a singular, or flagella, plural. Then we have types of bacteria. Some bacteria are photosynthetic. That is, they make their own food. Using inorganic substances from the soil. These are examples of the ones that live in the soil. We have chemosynthetic bacteria. Chemosynthetic bacteria. This one manufacture their food. Manufacture their food using simple inorganic substances from the soil. Inorganic substances from the soil. We also have another group of bacteria called saprophytic bacteria. That is saprophytes. Saprophytic bacteria. Decay and decomposition of dead plants and animals brings about decay or decomposition of dead plants and animals. We have another group of bacteria called parasitic bacteria. These are the ones that causes diseases in plants and animals, even in humans. So these are bacteria that causes diseases. They cause diseases. In plants, animals, and humans. So you see that we have classified bacteria on how they are. Let's look at reproduction in bacteria and then we summarize. Produced by dividing into two. Most bacteria reproduce by dividing into two daughter cells which are identical to their parent. And this process is asexual reproduction called binary fission. Most bacteria, that is, dividing into two daughter cells. Identical to the parent. This is the method of reproduction. Some of them can even multiply by multiple fission. That is why you see within a very short hours, bacteria can multiply and be up to thousands in an environment. And that is why bacteria can infect many people within a very short period. We have uses of bacteria or economic importance. Economic importance of bacteria. Number one, just as from what I said before, bacteria are of great importance. They are of great economic importance. Number one, harmful bacteria causes diseases in plants and animals. Causes death and decomposition of the plants and animals. Useful bacteria bring about decay improving soil fertility. Number 3, bacteria are also used in industrial processes. Bacteria are also used in industrial processes. Where bacteria are used to ferment many foods, like in our food industries and brewing industries. We also use some bacteria in industrial processes like production of some antibiotics. Most of our antibiotics are bacteria. Our antibiotics we use in pharmaceutical industries are mostly bacteria. Then let me quickly give you the general structure of a bacteria. Then we now call it a day, so that you see these bacteria we are talking about, what they look like. We are talking about them without knowing how they look like. So let's look at drawing. This is biology. You see how bacteria look like. Flagellum, which is used to move. You see the chromosome has the single nucleus. We said that they are one cell. You see, they are one cell organism. Chromosome, single DNA. DNA strand. Coil. Slime capsule. They have capsule. That's why they are resistant to heat. You have the cytoplasm. We have the cell wall. So this is the general structure of a bacteria. This is the structure of a bacteria. We use the flagellum to move. This one is a motor bacteria. Bacteria that moves. Then using the flagellum, you see the single nucleus. We say they are one cell, single cell. You see the one nucleus there, the slime capsule that makes them resistant to heat. You see the cytoplasm and the cell wall. So this is the structure of a bacteria. I think you enjoyed your class this morning with me. Thank you for paying attention.